Okay, it's going live on YouTube, so we are live.
Awesome. Great. Thanks, Nancy. Hello, everyone, and welcome to the third lesson of the bootcamp, Bringing Machine Learning Models into Production, brought to you together in collaboration with PyLadies Amsterdam and Dexter. And today we'll focus on a near real-time inference. So without further ado, let me start. Okay. Too fast. So what's on our plate for today? We start with a short recap, of course, as usual. Then we move to near real-time inference on Azure, what you need to do it, how to do it. And then we finalize with exercises and home assignments, so you know what is expected from you. Okay, so short recap. Remember, we are working in the direction of energy case. Right now, we are getting these lessons to understand how we could deploy the energy demand model, and that's something that is waiting for you and even more during the capstone. So what we did during the previous lesson? During the previous lesson, we covered a lot of things. We did data preparations, 2 models, actually 1 model training, model evaluation, and the model registration. And your home task was to train another model, evaluate it, and register it as well. While doing this, we were doing it in a hybrid setup when we are using our laptops or personal computers as the local compute, and the data set were registered on Azure. During the model trainings, all running experiments were written to Azure, and the model was registered to Azure as well. And then we moved to the batch inference on Azure by using Azure Machine Learning Pipeline. So we learn how to set up this pipeline, how to prepare score.py file, conda inferencing environment, and then we are working on the creation, publishing, and as well as scheduling the pipeline. And we did this for 1 model, and your home assignment was to do it for another model. So a lot of things happening, and now probably you're wondering, okay, but why we need to know and learn anything about near real-time inference? What's wrong with our Azure machine learning pipeline? What's wrong with the batch? So in case with batch, what we were trying to predict, we were trying to predict the energy demand for the whole week. And how we were doing it, we were waiting until 168 files, which correspond to 168 data points, is landed to the blob storage. And then we have an Azure pipeline scheduled that was ready to pick up all these 168 files and make 168 predictions that correspond exactly to predictions per hour for the next week. So it's nice if we know that we have some delay with some specific data that we needed. So we know that during the week we can collect this data. So let's say we're collecting the data until 11 o'clock in the evening on Sunday, and then on 00 or 0 o'clock our pipeline starts. And as soon as we arrive, let's say at 8 o'clock in the morning to work, then we have our predictions ready, and this predictions for the next week. But what if we don't want to wait? What if we want to make sure that as soon as the new data point arrives for the previous hour, we are making predictions for the next hour? In this case, we also can follow the old pattern, but to set up the pipeline that a specific time will be starting and giving predictions back. But remember, last time we need to wait at least 10 minutes for compute to be provisioned and to start the processing. So there is some huge delay. And if I want to get my predictions for the next hour, just to spend 20 minutes on processing is a little bit too much. So if you're wondering what are the other options, if I can give the data points and get predictions immediately back, that's exactly the situation with near real-time inference in Azure. But before moving to this part and starting coding, I would like to pinpoint some common mistakes that actually we noticed during your homework assignment and during exercises that you were doing. Exercises were created just to let you become comfortable with some specific tools, and home assignment was created more end-to-end to make sure that you can pick up the data processing and finalize it with the scheduled pipeline. So the common question that we get, I have issues with config.json. So config.json, it returns errors. It doesn't matter what I do, it gives me errors. So in this case, you should be really, really careful while you are actually editing this file. If in some way you added some extra characters and you didn't notice it, then you can get an embedded JSON, and that's why you get this all complaints. Another story was about some issues with conda environment, where it was giving you some errors or saying that, oh, you get incompatible libraries. We did it deliberately to make sure that in lesson 4, we show you the best practices of handling conda environments. And I think that's it. And of course, if you know, for those who are participants of our bootcamp, who are right now supported by their teams and mentors, if you have any question, you have a chat for it, you have a place to ask, and no questions are weird. But remember, if it's a technical question, remember to submit as much information as possible to make sure that you can get your answer back. But okay, without further ado, let's take a look what is waiting for us and the near real-time inference on Azure. So what we're going to do today, we're going to learn how to work with so-called serverless approach. Although serverless has servers in it, but some parts of server management and other constraints are removed for you by the cloud provider. So in this case, you need to focus only on writing the logic of the function that's going to perform some actions on your behalf. And in our case, we're going to work with so-called Blob-triggered Azure function. So how it works, as soon as the data in a specific format arrives in the specific place of the blob storage, it triggers our Azure function. In our case, it will be our model that reads this file, make predictions, and writes it back to another place in your blob storage. So in this case, you get immediately your prediction back. And it will not take a lot of time. Usually it's a pair of milliseconds, so it's really efficient. And if your end product, for example, is a dashboard, then you make sure that your dashboard will be updated as soon as new data points are landed. So it's really nice. And what we're going to do today, we start with just a simple standard template for blob-trigger functions. Then we do some small things to make sure that we have everything to run it locally as well. And I will show you why it's important to know how to run it locally. We're going to do it with Azurite. And then we finalize with the blob-triggered Azure function that will read the file and give predictions back. So that's our plan for today. It's a lot of things that is waiting in front of us. So let's start. Okay, so now I'll switch off my camera and then move to our familiar Visual Studio Code, right? Okay. So last time I mentioned that the beauty of Visual Studio Code, that because it combines a lot of things in it, and the biggest advantage is extensions. At the lesson first, you were prompted to do a lot of installations, and among of them were to install Visual Studio Code with a set of extensions. And probably you're still wondering, why should I do it? Now you will see why. Also, I got questions, okay, why I should work with Visual Studio Code if I get used to work with PyCharm or Spider. I have nothing against it. If you feel comfortable working in your IDE, do it. For this use case, I decided to work with Visual Studio Code because that's what I'm using just every day in my job. And it has all extensions needed. I work with 2 clouds. I work with Azure and AWS, and also with a lot of on-prem setup on Kubernetes. So in my case, it's a unified tool. And also while working with different languages such as Scala. So or Java, it gives you, let's say, much more space than just using one specific IDE. That's it. But okay, so let's start. So the first step will be to make sure that all prerequisites are there. And by prerequisites, I mean that I have a resource group, I have a workspace that we made actually during the lesson 2. I have a registered batch data dataset. I have our trained, validated, registered models. And also I have my config.json in the root folder. So with these things here, I can start. But if I want to verify whether I have all of this, I can do it or via command line, or I can use an extension. Finally, you will say an extension. So now I'm moving to Azure and I'm opening the machine learning extension. I updating it to make sure that it gets updated information. This line will look different for you probably. It was just the name of your subscription. Okay, so it confirms that I indeed have a workspace called MLOps. And if I go there, to the datasets, it confirms that I have indeed registered these datasets as tabular data and the batch data as a file dataset. Of course, I can explore further, but regarding the models, I got to check. So I have 2 models registered, linear regression as a result of the lesson 2, and then Ridge1 as a result of the homework for lesson 2. You can also check whether I have more there, but that's enough. So that's just a quick way to double check whether I have everything to start with. So now what I'm gonna do, I start to create Conda environment. So in my case, I'm just going to my folder. But before that, let me check out to another branch. Okay. So to make sure that I didn't anything wrong, and a master. Cool. So I'm going to this folder, Bootcamp lesson 3. Great. So I'm right now in a black lesson 3 folder, so I can start. Here I have a Conda environment. So the first thing that I'm going to do, I will create a Conda environment based on this YAML file. Probably you can say, okay, why not to reuse the Conda environment from the previous lesson? Okay, MLOps function YAML, great. Because Azure functions require some specific sets of libraries that is not needed for model training or for batch inference, it's better to keep environments separated. Okay, so now it's installed. Let me activate it. Conda activates, and it's MLOps. Okay, I have MLOps train, MLOps function. Great. Then I'm going to select my Python interpreter. I will update to make sure that I see this environment. Okay, MLOps function Conda. Okay, we all set up. Next thing that I'm gonna do, I want to make sure that I log in. Okay, it's redirect me to make sure that it's there. Cool. Okay, great. So now we are there. What I'm going to do before starting to develop anything, I want to create a new folder called blob function and put it in this lesson 3 folder. While I'm doing this, I will show you now my making directory and then go call it blob function. Blob function. Cool. So, why? Because when we're going to develop Azure function, everything that will be in this folder will be packaged and copied and deployed to Azure. I don't want to grab everything that I have in this repository. I only have grabbed things that are in this folder. That's why I built in a separate folder in this lesson for this function. And now it's time to use Azure function extension. So I'm going back to Azure functions. Probably have here more and less, it's not a problem. And I want to make sure that it's the right subscription. Great. So now what I'm going to do, I'm going to actually create new project. So if I hover here, it gives me the name of the icons. And the first icon says create new project. Okay. Next, what I want to do, I want to use browse. And by use browse, I want to make sure that I'm going to the folder blob function, because I want that my templates for this function will be created exactly in this folder. Select, then it's asking for a language, so I'm selecting Python, that's what we're going to use. Next, it's asking me to select a Python interpreter to use to create a virtual environment here. Because I have a lot of options of Python installed with different content environments in my machine, I wanted to make sure that the specific Python from this specific MLOps function environment will be used there. So now you see that I'm an MLOps function. So if I want to get a path for the interpreter, I just type here which Python. It actually gives me the absolute path to the Python interpreter in this MLOps function environment. So in this case, I just copy it. In your case, it will be look differently, especially if you're on Windows. It will look completely different with slashes in the opposite direction. So, and then I actually I'm choosing manually enter Python interpreter full path. And here I give the path to my interpreter. Why? Because I want to use Python that it's not somewhere on the machine, but the Python that exactly exists in this specific environment. Okay, cool. Then it asked me to select a specific template that I'm going to use. We're going to work today with Azure Blob Storage Trigger. So in this case, I'm just picking this Azure Blob Storage Trigger. And then the next step is to give a proper name to it. I don't like to keep generic things like blob trigger. It doesn't say me anything. I know that I'm going to deploy a linear regression function, so I'm going to call it this way. I'm going to call it linear regression, so LR for linear regression, and then blob trigger. Okay, LR blob trigger, great. Next, it asks me to create new local app settings. Okay, I'm good to go with it. Next, it's asking me which storage account to use for it. So your storage account will be named MLOps storage, and then it's a random numbers and digits. So make sure that you pick up your own storage account. Don't look for my storage account in your setup. So I'm picking up this environment. And next, it says to me that you should pick up a path that will be monitored, that our trigger will be monitored. So I want to create a path, so I replacing it with the following. I replacing it with predictions input. That's the container, that's just a fancy name for folder on blob storage. So this is there will be the path in my blob storage for the specific container predictions inputs. So I'm getting predictions input, and then I want that my function will be triggered by any document. Doesn't matter what's the name of the document or what is extension, just any document that I will drop in predictions input container will trigger my function. So that's how my function will be executed. Okay, so I define this, I put enter, predictions input, great. So what's happening right now, you see something goes on in the right corner. So actually right now the constructor creates something for me and it says finish creating project. Okay, so what we get, let me close it for a second and get back to here. So what you see happens, you see the blob function was created. Ooh, there are a lot of files there. So what I see here, first of all, I see here the virtual environment that is waiting for me to be activated. Then it's created a folder with something in it, and then a lot of other files. Remember, I mentioned that everything that will be in this folder will be packaged and deployed to the cloud. That's why we create a separate folder for it, because we don't want to grab our lesson task slides and the rest of the repo there. So here in this blob function, what we're doing right now, we're going to explore what we have in this folder, blob trigger. So that's the meat of our function. It actually consists of two files, init.py and function.json. The rest is README file, sample.dat file. It's just a file to play around to make sure that the function is working. Func ignore works exactly as a git ignore. So git ignore says to your git which files or extensions not to save, and funkignore do the same. So if we open funkignore, it says don't pick up anything from venv, test, local settings, JSON, VS Code. So package everything in this folder except these files or extensions. And then we have host JSON, and then we have local settings JSON. We go back to it a little bit later. And we have our well-known requirements.txt file. That's the file will be used to list all dependencies, and it will be used during the deployment of our function in the cloud. Remember last time what we were doing? We were actually creating score.py file. The goal of score.py file was to first init, and init we had a model load. We just load our pickled model and actually starting using it, unpack it or deserialize it with a joblib library. And then we have a run minibash function that was actually going through the list of files. It was opening files, reading it with numpy, and then actually write predictions back to the file. So actually think about initpy as this file. So let's take a look inside of the initpy. So now we have it's to imports, login, Azure functions as func, and then something that happens here. And we have as well function JSON file. The function JSON file is the file that is used to describe in and out things that we're gonna put in the blob or we want to write to another blob. So what I want to do right now, I want to show you how to update this function a little bit. It's not a prediction function yet. It's just a function that's gonna read, that will be triggered by a file that will be added to the blob. And then it will be just writing something back. So let's define right now what we will be writing back. So if we go into init.py, the things that I want to change here is as follows. First thing, I want to say that I have, inside of my blob, I want to have input blob. So I want to rename, change all occurrences, and I want to replace it with input blob. Great, input blob, awesome. Input blob, that's the direction that I'm getting something with the trigger in. So as I'm going here to the trigger, I need to replace this part to be corresponded to the input blob. If I have this right now, I have input blob here and input blob here, we will know that as soon as something landed on the blob, it will be trigger this main function and the main function will run. So now I have input blob, and what I'm going to do here, I want to make sure that I'm not just getting something in, but I getting something out as well. So for now, I just want to define, getting back, go to the wrong place. Okay, Control C. So let me define here as well the output. So I can call it output blob. I can call it predictions. Let's call it predictions because that's what we aim to output with our function later. So let me call it predictions. Predictions. Great. And then define what it is. What I'm doing right now calls type hinting. Actually, I define just two variables, two arguments, input blob and predictions. And what I'm doing further after this column, I define what type of, what kind of object it is. So input blob, this is a function, Azure function input stream, and predictions will be out with a definition of string. So in this case, it will be func, it's function, it's out because I want to write something back to the blob storage. Then I want that something that I write will be just a string. So now I have input stream and output stream. And to make sure that I'm putting something in the output, I want just to add here one thing, and it will be, let me go there. So make sure that it's kept in the function. Let me say like result. I just define the variable. and then what I want to be written into the blob-wizard file. Let's say hello world from MLOps Bootcamp. So, and then I want to make sure that my predictions actually, I call the set, and what set is doing, it's set something as an output in this case. So result. So what I'm saying, as soon as the files come in, it's trigger my function. It doesn't read the file per se. It just give me back some, let's say, metadata about the file. Okay, what's the name of the file in the input blob? What is the length of the file on the input blob? And after it's, let's say, done with this, it's create variable result, assign this string, hello world from MLOps Bootcamp. Let me add the exclamation sign over here, and it will just say, okay, this is my output predictions, and just I want to put it into the file. But as I mentioned, we have in, this is the input blob, and we have out is the predictions. There is one thing that is missing actually in the definition of predictions in the function JSON, because I have here only direction in, but I don't have direction out. So I'm not defining what I want to see. What I'm defining here in the function JSON is just information how I want to run my function. I'm saying that use this Python file, init.py, that's file that we're working on right now here, and then use so-called bindings. We define this is the input blob. It will be triggered when in this path we will see something popping up, some files. It doesn't matter which file with which extension. What's important that this file will be added there, or it will be file that will be updated there. And then I just want to take this file and get metadata from this file. So what I'm gonna add right now, I want to add out for it. So output for it. Okay, so for the output, I need to define the name as well. So I have name, we have input blob, and guess what will be the name for this? It will be indeed predictions. So get me back, it calls predictions. Great. So I know that the name will be predictions. Next thing that I want to define, it should be type. What kind of type it will be? It will be a blob. And by the way, what blob is, think about it just as a file for now. Blob, then direction. Now you probably could guess what I want to choose for out, for direction. Of course, it will be out. Great, so direction is out. What else would I need to add? The question is, where do I want to drop my file? So if I drop my file at the same blob, I will go into the actually infinite loop, because the function will read file and generate something. So in our case, it will write the string to the file, and as soon as the file will be dropped, it will be triggering this. I want to prevent the situation, because in my case, I will be expecting that in predictions input, I will get some files to make predictions on. So I want to have a separate file. So I'm gonna call it surprise, surprise predictions output. In this case, I can split it, and I'm saying the predictions output, and let's just use the same name. So it means that if I drop a file called sample.dat, then I will get in predictions output sample.dat as well. If I get one .csv file, I will get one .csv file as well. The difference will be that the one .csv file that goes in looks different from the file out, because in our case, what we do is our function, we just write in the string hello world from MLOps Bootcamp there. Okay, great. And the last thing that is needed here, actually, it's the, oh, I don't intend to put dot here. It's gonna, I need to add connection. You see, it's helping me already adding connection. So the thing regarding connection, what I want to do here to make sure that everything working correctly and I don't do anything extra, probably, okay, let me keep it right now as it is, and then I will update it, or better update it right now. Okay, no, let me, okay, probably let me better update it right now. Yeah. So what I want to do, I will say that this is, the connection is, I will explain later what does it mean, it's storage connection string. It's an important thing, and we'll get back to it in a minute. I think so. Okay, so now I can save it. So what I've did so far, I want to double check everything. So I have function JSON. The function defined that the script that should be run, it's init.py, it's correct. And then I have bindings. I have input bindings that says input blob, this blob-triggered function. As soon as something will be in predictions input, it will start doing something. Start doing something described right now in my init.py file, and then something that I did in my init.py file, the result will go to out to this predictions output place. Okay, sounds nice. The function JSON is defined. I can close it now. This part is defined as well. We don't import any other libraries here. We are good to go only with Azure functions. Let me check requirements.txt. It contains Azure functions indeed. So nothing added there. Okay, we have function, it's doing this. Right now, the PyLens is complaining as a missing import because it doesn't see the Azure functions installed here in the MLOps function. It's just an empty environment with Python 3.8 installed. But for now, let's keep it as is. Okay, so we have it. And to make sure that it's going to work, what I want to do first, I want to actually create predictions input and predictions output containers in my storage. And for this one, I'm going to use, let me just make sure that I save it. For this one, I'm going to use actually extension again. So I'm going to Azure and I'm picking up extension called storage. So yeah, it's just making sure that's my storage. Your storage will be named MLOps storage and then go something further. And the storage contains from blob containers, file shares, queues, and tables. And we working with blob containers now. So I'm going to blob containers. You see a lot of things. That's exactly what we get from the previous lessons. So now what I want to do, I just want to create two containers, prediction input and prediction output. It's easy to do. What I'm going to do, I'm just clicking here and it says create blob container and I give the name. So it was predictions input, correct? Let me create it. Voila, and I have right now a predictions input container. And I want to create predictions output container. Create predictions. I'm checking my spelling. Output, predictions output, predictions output. Okay, so that is predictions output. Okay, cool. So now I have predictions input and predictions output. There is nothing here. I just created this two blob. Okay, great. So the next thing that I'm going to do, I want to deploy my function. So here we go. Here, there's my function. I can go to the here to the LR blob trigger. That's what I saw, right? That's my function. And what I want to do right now, I want to deploy it. So this is Azure Functions Virtual Studio Code extension. I'm just select my functions and I click here to deploy it. So now it's asking me, where do I want to deploy my function? Usually, Azure Functions will be deployed as a function app. So because right now I don't have any function apps in Azure, I need to create one. I'm going to pick up advanced. I will explain later why. So I'm going to pick up advanced, and now it asks me the name for my function app. So because my function calls LR blob trigger, I want to call my app LR blob trigger app. By the way, it's a good practice to follow so-called naming conventions. So if you're working together with other people, there's always some things about how to name stuff. So it's better to follow it so everybody knows what to expect regarding naming. And it also removes a lot of confusion. So LR Blob-triggered app, great, I give it the name. Select a random stack. In my case, I'm selecting Python 3.8, great. Then it asks me which actually resource group to choose, and I'm going with my MLOps Bootcamp resource group. Okay, it says it can't be preloaded. Okay, reload window. Let's check. Just make sure that we're in the right place, that everything is there. Yes, we're here. Great. Lesson 3. Just let me check that I'm in the... okay, I'm already in lesson 3. Don't need to move somewhere. Okay, so let me get back to here, to my functions, and then get back to deploy. Okay, so create new function app. Let me put the name again, LR Blob-triggered app, LR Blob-triggered app, great. Select random Python 3.8, select resource group, yes, it's an MLOps Bootcamp. Select the region, select location. In my case, it's West Europe. In your case, pick up your location where your resource group is located. And then there are 3 types of what to choose. The simplest and cheapest one is a consumption plan, another one is premium, and another one is app service plan. I'm gonna choose for premium one. It's a little bit more expensive, but it gives you much more flexibility, and it allows you to run, for example, Linux app with custom Docker containers that we will need a little bit later. So I'm picking up the premium function. On top of it, if I pick up consumption, then my function can experience so-called cold start. It means that it can wait at least 10 minutes. If I need to make predictions fast and I want to get a response within the first response, at least within a short time constraint, it's unacceptable in my case. That's why I'm going with premium. And for those who are running free tier, it's not a big deal, but just to make sure that after all things, you will stop your function and there will be no charges incurred further. Okay, so I'm picking up the premium hosting plan. Now it asks me to select a Linux app service plan because I'm going to work with a Linux app and I'm going to deploy an app running on Linux. So I want to create a new app service plan. So it gives me the proposal how to name it. No, I don't want to name it like this. I want to use it MLOps and then call it plan. So that's the let me just first check and then I give a short explanation about it. I'm going to pick up the cheapest pricing tier. In this case, is Elastic Premium EP1. And once again, I need to pick up a storage account. In my case, it's MLOps storage and then ghost numbers and ciphers. In your case, it will be MLOps storage and then your random numbers. And then it says select an application insights. So when we were deploying our machine learning workspace, it's spin up extra resources with it. It's spin up a storage that we're using right now. It spin up a keyboard. We will talk about it later. It spin up application insights as well. Why do we need it? It's to monitor and actually collect the logs that we have. So I'm going to pick up the MLOps insights. This is my application insights resource. Your will be named after MLOps insights and then again random stream. So I'm picking up this one. And now what's happening? Now the plan is created. So what we did so far, we want to deploy our function. To deploy our function on Azure, we create a function app. So one function app can actually contain not only one functions, but more. And it depends on how you're going to run your function. If you run your function without Docker container, then there is a possibility to have 3 or 2 or more functions running within one app. And if you have a custom Docker container, then there is just only one function per app. And regarding the service plan actually is capable of hosting a lot of different apps inside of it. So think about like hierarchy. You start with a service plan, then you go to the apps, function apps, and from the function apps, you go below or go down to the Azure apps. So what's happening right now, our function right now is packaging and be deployed to Azure. So let me wait for a second. And as soon as it will be deployed, if there are no things, we can just check output window for status. So you see it's saying create a zip package. That's what I told you. So if we go back here, so what's happening right now, it actually collects everything that is in this folder blob function. It creates a zip file from it, and it just sending this zip file to be deployed on Azure. So app is created, we just need some time. It's preparing and deploying and running. So that's the process that going running. Okay, it looks like it's almost deployed successfully. We can verify it as well here. I just can update it. So if I update it here, you will see some more things. Okay, it says deployment to LR Blob-triggered app completed. Great. So now our function that we created locally is on the cloud. I just want to refresh it to show you you see? So before that, we have only local folder, local project. But now if I go there, I have here more. I have here functions, application settings, files, log deployments, and even more. The one thing before seeing how our function works that is missing is the so-called connection stream. Because our function is listening to the blob storage, I need to point out to where exactly our function should be listening to. So now what I'm going to do, I'm going to copy the connection stream from the storage. So I'm going to my storage. I just wanted to make it higher. This is my storage, envelope storage. And here I can say copy connection stream. It's important to copy connection stream, not key or something different. So copy connection stream. Right now, the connection stream is in the buffer. So now I'm going to this Blob-triggered app, to the application setting. That's the default application settings. Let it retrieve it. That are right now in the cloud. And I want to add the new one. So I'm adding new setting. And now what is really important, I need to create a new key value pair. And the key will be actually the thing from our function JSON file, and the value will be my connection stream. So let me just, I put escape for a second, and I want just to go there, and I want to make sure that my function JSON, you see here we have connection, storage connection stream. That's where how my function will be listening to the blob storage. So I call it storage connection stream. And the same name of the key should be. If I mistype the key, the function will not be able to connect to the blob storage and will not be able to do its job actually. So it's storage connection stream. So I'm getting back here to the application setting. I'm saying add new setting, and I type it really, really carefully. You see I'm starting with a locate, and it should be with, so it's storage, then it's connection, and then it's stream. By the way, you could call this connection anyway. You can call it my connection stream, blob connection stream, stream. You can call it, I don't know, like body, whatever. But the best practice is to follow specific conventions. And if in your company you decide that the better way to handle it and manage it to use this specific key, please stick to it. So now I'm adding the key value pair to my app. So storage connection stream, this is the key, storage connection stream, great. And then enter the value. And I'm just entering the value that was here. You see there is a long thing. It starts with default endpoints protocol and edit with core Windows Net. Enter. So now it's creating the application setting. Before, if this thing is not done, I will not be able to run my function in the cloud. So what do I want to do right now? I want to test my deployed function with Visual Studio Code extensions. I can do it as well, actually via Azure portal, but going back and forward costs time, and I want to minimize this time. So what I'm going to do right now, this is my storage, and this is my container. Remember, our functions is listening to predictions input, and it will write down something to predictions output. So what I'm going to do right now, I'm just clicking on it and select upload files. And in my function, actually, there was like a sample.file, it just to test my function. Upload, prediction outputs. And I always forget to tap enter after that because it says enter the destination directory. In my case, it's enter. So now it says upload in the predictions input. Successfully upload to predictions input. Let me check it out. We need to see it. Okay, so now we see sampled out there. And let me check predictions output. Voila! You saw I didn't put anything in predictions output. So because it was just empty container, let's open it to make sure that it's exactly what our function is doing. Hello world from PyLadies Bootcamp. Congratulations, it means that you deployed your first app. And now if we want to see what exactly we typed into our init.py, what we wanted to see, that's our function, right? So what I can do here, I can go and take a look at the logs. And by the way, you notice that we didn't use print function here. We use a really important Python module called logging that help us to write logs. So we have here login info, and we want to actually write this information down. It's our metadata about the file. So if I go to logs, it says read only, and then from logs to application, functions, then in the functions, I want to go to functions. So let me just update this to make sure they have everything here. So I have application, functions. The house is not there yet. Okay, but anyway, we can check. We can check it in another place or connect to the log stream. Let's give it for now, or I could probably show it in here. So if I update, now you see the following. This is my Blob-triggered app, and this is my MLOps plan. So if I go to our Blob-triggered app, it shows me something about my function. I want to explore what is there. And then I want actually to see what's happening. So I want to make sure that it is exactly the function that I deployed. Yeah, so it looks like this. Hello world from PyLadies Bootcamp. Great. I see as well here function JSON and the rest of the things. And I can just check how it works. So actually there's this trigger. It's Azure Blob Storage Input Blob. There is my function. And then the output of the function, it's the prediction that go to Azure Blob Storage. Great. And if I want to check the control, what's happening, I can actually open the function and check. Okay, up. It's a little bit too early. It's, wait a second, alt logs. Let me remove it. I want to see the latest one. Sometimes there is a short delay in between. So today is it's not the 30th of July. Okay, it's not updated yet. But anyway, so okay, now we have our function that is working. And what we want to do, we want to update this function in this way that actually we can upgrade our function. But only one problem with this approach, if I'm gonna, every time I need to update something and then to deploy, update something, then to deploy, it's a little bit like a guessing game because I don't know, I'm not sure whether my code is working, I'm not sure whether it's everything okay. So in this case, what do I want to have? I want to set up right now a local dev to make sure that I can work with my function, develop my prediction function locally and test it. And to do this, I need some specific components. I need to download test data. I need to download our models. And then I need to start Azurite. Azurite is extension for Visual Studio Code, and it was as well in the list of extensions that should be installed. Why it's important? Because otherwise, every line of code that I will be writing, I will not sure whether it's running or not, and I will spend a lot of time and money if I'm going to test it with a real blob storage. So in this case, I will going to use Azure to emulate my storage locally. So literally, it's not necessary to do any connections to the cloud. I can just do it locally. Without this emulator, there is no way to test my function because I need to emulate the storage. So I'm going right now to the terminal back. And the first thing that I want to get the test data for me. So to get the test data for me, I want to actually go to the extension, and I want to download the data. So in your case, your batch data, registered batch data, will be on Azure ML/blobstore/random numbers, random digits. So just let me go there. This is my batch data. Let me check. Yes, this is the batch data registered, right? Registered last time. So what I want to do right now, I'm just saying download. I want to download them locally, and I'll go to browse, and I want just to dump this file to the lesson 3 folder. Okay, let me say open. What's happening right now, I'm downloading from the cloud a batch data. You can say, wait a minute, I can just copy this folder from the lesson 2 locally. In this case, I'm doing this for only one sake. I want to make sure that I'm using the data that was used exactly for model testing. So that's why I'm downloading them from the cloud. So here I have batch data. Hello from batch data. Great, I have this. The next thing, what I want to do, I want to create a new folder, models, and download there some models. So right now in lesson 3, I'm just creating models folder, NPDR models. Great. So I have this folder right now. I know that I have 2 models registered on Azure. So what I want to do, I want just to get list of all models that are registered in my workspace. And I'm doing it by using Azure CLI. So I say Azure ML model list. Model list, then my workspace name is MLOps. And then my resource group name is MLOps Bootcamp. So what it returns me back? It returns me back 2 models that I have. One model ID. I need model ID. Of course, you can retrieve it in another way. I'm just showing you like the simples, probably. So what I need exactly this ID to download my model. So I just will gonna copy this ID. And now what I'm gonna do, I'm gonna download the registered model into the models folder. And I do it with CLI as again, Azure ML model, download. Then I go that goes ID of my model. In this case, it's linear regression 1. Then goes folder where I want to, this is the target folder when I want to download it. In my case, the target folder name is models. Great, so models. And then I need to point out again to workspace and to the resource group. MLOps. Oh, bootcamp. Okay, great. So now what I'm doing, I'm loading one model. And after that, I want to actually download another model as well. You see, I get just linear regression pickle. And another story will be, I want to do Azure ML model. And of course, just type repeat. I'm going to type it out for one specific reason. And this reason will be discussed in lesson 4. So, it should be not linear regression. It should be REG. It should be REG 1. In your case, if you registered more models, you can get REG 2, REG 3, REG 4 based on the version of the model. In my case, I'm working with REG 1. Target folder, I want to land it to the models here. And then So our workspace MLOps, and then our group is MLOps Bootcamp. So I want to make sure they have both models, so then you can work at home later with the second model as well. Okay, great, I have this. So only one thing left before we start, like tiny things, tiny thing that's waiting for us. It's start the Azurite. So for this one, I'm going to use Azurite Visual Studio Code. So for those who are working on Linux or Windows machine, you have a combination. If you're in Visual Studio Code, you can type Ctrl-Shift-P. And if you're on a Mac, like me right now, I'm going to type Command-Shift-P, Command-Shift-P. And it's opened me just a console where I can pick up any commands that I want. So in this case, I want to start Azurite. I want to start my local emulator. So I'm going to say Azurite start. And it says starting Azurite. So what's happening right now, if I'm going to go to the storage, let me open it like this. You have attached storage accounts, and attached storage accounts, in this case, it will be my emulator. So I just review it. So when I go here, it says local emulator, and it has blob containers and queues. Why it's important to start blob containers and queues? If you just start blob containers, nothing will work, because to make sure that it's working, behind the things, there is a queue that played a role. So queue just delivered a message that something changed in the blob container, or a new blob added, or a blob updated. And this is exactly what triggers our blob function. So make sure that you start both. I just pick up start everything and starts blob, queues, and tables. We don't use in tables here, but make sure that you spin up both. If you just spin up blob containers, you will get a trouble, because your function will not work locally. So what I want to add right now, in our real storage that is here, I will just hit it. We are created 2 blobs, and I need to do the same here. So what I'm gonna do right now, if it's working, I need to create blob container, predictions input, because it's emulation of what we are doing, predictions input, great. And I want to create another container that calls predictions output. Predictions output. Okay, predictions output. Great. We have both predictions input, predictions output. The next thing that should be done, we need to update one file. So we have local settings JSON. This file right now is in a git ignore. So it means that this file will not be saved to the Git. It will not be committed to Git. So what's this file? Why do we need this? We need this file for local development of the function. When we deploy our function, this file is usually ignored. So now I'm getting in this local settings JSON. And there are 2 things that should be updated right now. So when Azure Functions is working, it needs some place to place its logs. And this logs is usually placed under the path of Azure Web Job Storage. It's just default way. If you want to see what's happening here on our storage, real storage, blob storage, if I go to blob containers, you see Azure Web Jobs host and Azure Web Job secrets. That's the 2 containers created specifically for our function that were created automatically, by the way. So in this case, when we're going to develop locally, we need to add here a string, a connection string. And because we are working with Azurite, Azurite is an emulator of a real storage. We are using the so-called developer connection string. So let me copy it. Don't worry, you will find this information in the lesson 3 theory. So if you go follow the instruction, you will not miss it. Okay, so right now I added, let me just check. It looks like this. I added this information here. Let me just make it up. Great. So you have queue endpoint, blob endpoint, everything. Now it's a little bit complaining because let me check whether I'm capable of, yes, adding this here. Great. And there is another story. Remember, we replaced in our function JSON file, we replaced this value. So we need to replace it again. So actually what I'm doing right now, I'm just adding the same string again. Okay, let me get back and first add a dummy. Okay, so let me just first add, I just want to add double quotes. So, okay, so let me just add double quotes here, and that's it. Yep. Alt, and one thing is missing here. It's actually double quotes here. And this thing should be replaced with, let me check, storage connection string. It should call this way. If it will be not this way, I will not be able to work with it eventually. So now I have this, so it looks valid. Why I also love to work with Visual Studio Code. So to get rid of the situation when I create a JSON file, but somehow I passed there something wrong, like an extra character or extra empty character. Actually, if your JSON file is invalid, you immediately get notified. So it will spare you as well a lot of time, because you see immediately that your JSON is valid right now. So what we did so far, we go to local settings JSON. This is the file that your function is listening to while you're developing locally. And we just give pointer to two storages. It's, in our case, the same storage. It's our emulated storage. And we pass there the connection string, the storage connection string, and it comes from Azurite. So now we did it. The last thing that it left before actually developing locally. So now I can close it. I can close this file. So right now in lesson 3, great. What I want to do right now, I want to go into the blob function folder. Great. So now I'm blob function to make sure that I'm here. And what I want to do, I'm going to activate the virtual environment. So there are different versions how you can activate it. So here you see this is the name of my environment, .venv. Because I'm working on Mac, it's one way. If you're working on Windows, not in a Git bash, there are another way to do it, and I add it all in the comments for lesson 3 theory to follow. So probably you can ask me, Alyona, what we are doing? Why we are creating virtual environments? Because we are already in Conda. Why do we need a virtual environment inside of it? Our function, actually, when it's packaged, it's picking up a requirements.txt. So I want to make sure that everything that will be in requirements.txt will be capable of running our function. And that's the difference with working with conda install and pip install. Because conda install and pip install manage installation of the packages differently. So that's why I'm going to work in a virtual environment to make sure that everything that's going to be installed here will be with pip install, and it will be reflected in requirements.txt. So when being active, come on, activate, okay. So now you see, now I'm like now I'm right inside a virtual environment in my MLOps function. Great. So we did it. The last thing that it started, I will start my function, and I will use func start. So for those who get some errors while trying to run func start, I want to say that this is probably because there is some installation that goes wrong somewhere. So make sure that the lesson 1 installations home task, Azure Core Tools installed properly so you can call func start. So what's will happening right now? Right now there will be, I'll just skip this for now. So what's most important, it looks like my function is running right now, but it's running locally. And to make sure that my function indeed is working locally, this is my local emulator. What I'm going to do, I'm just going to drop a file here. So upload file. And what I'm going to drop here, I'm just going to drop this sample.file. So enter, uploading prediction input. It looks like it's working. It says succeeded. Okay, so it says executed. Great. And you see what it says: Python blob trigger function process blob, name predictions input sample dots, blob size 30 bytes, and executed. So if it's executed correctly, oh, by the way, you see this Azure Web Job just popped out. That's exactly what my function is using to drop logs there. So let me make it bigger. As input, sample dot, let's take a look at output, sample dot, let's open it. Hello world from a Bloob's backend. So that's exactly conclude that my function is working. And right now I can start editing anything that I want in this function and actually developing my machine learning function. So what I'm gonna do right now, I'm gonna go to the meat of my function, init.py, and I'm gonna work there step by step to make sure that I have everything here to write predictions that I want to the file. Only one thing, because we are developing locally, I want to make sure right now that I can actually first load model locally. To give, let's say, I want to take a quick look at my score.py file that was created last time. Let me just briefly load it. What I'm gonna do, I can just copy it for now, and I'm gonna show how we're gonna process this file to make sure that we can run it on Azure function and when it's processed in the right way. Okay, so let me just copy it. Is it? Okay, so I don't actually need everything. I'll probably just go there. So just copying blindly for now, because that will be the core that I'm going to use for my blob trigger function. So let me just drop it here for some moments. As soon as I drop it, you will see immediately that something, if I just save it, yes, this exactly will be like some issues that it don't understand what's there, and there are a lot of things going on. So let me just remove run mini batch, and let me keep this logging. I want to remove this logging and just close this. And of course, I missed this part. Great. So the first thing that I want to do, I want to load my model. And I want to create the pod. So that will be the first part of my function in the main for now. I will get a model and we'll be loading it. And another one, what I'm gonna do, actually, I want to make sure that I'm getting data. So I'm getting data, then I do actually like prediction, and then I write real prediction and of this to this one. Of course, there are lots of things going on. So first thing first, what is missing? The joblib library. So I need to use joblib library and import joblib library. Then, because my model is using scikit-learn, I want to have here this. Oh no, I don't actually need import it because I don't call it directly. But I'm going to do some transformations with pandas. So I'm just do import pandas as PD. Then I'm doing import pandas as PD and import numpy as np. That's probably what I'm going to need. What I'm going to need as well for now, I want to do it locally. So I want to import OS function as well. So right now, you see it's going red because the function is working locally right now. And what's happening says I couldn't actually import joblib. And it's true because model not found error. It's okay, but it's immediately notifying me that, Alyona, you need to add something to requirements.txt. So in this case, I'm just opening requirements.txt and say, I want to add here joblib. I want to here scikit-learn. I want to add here pandas. What else? Joblib, pandas, numpy. I don't need to install numpy because scikit-learn has dependency on numpy and pandas have dependency on numpy. That's why it will be installed. It should be installed. So let me check. And then, okay, Azure functions. For now, model, it's from, okay, let me add it as well here. So let's say for now, import Azure ML.core. no, not import, from Azure ML Core, import workspace, and import model for now. Not the best way to organize your import, but we'll discuss it later. Okay, so now what I'm checking, I have Azure Functions, JobLib, scikit-learn, Pandas, and I need to add Azure ML Core as well. So Azure ML Core. Okay, so I'm just saving it. And right now I'm in the terminal. So for now I will stop, and by stopping it I do Control-C. Of course I can open another window, but just want to make sure that I'm here. So what I want to do right now, I updated my requirements.txt package, and I want to install this package to make sure that I have everything to develop my function. So I'm doing, right now in virtual environment, pip install here, and then goes requirements.txt. So let's wait until it will be installed. Some installation taking place, because I want to make sure that my function has everything in its installed via requirements.txt. So while it will be packaged, it will be able to run, actually. So sometimes you need to wait a little bit until the installation will be done. Okay, it's okay that it's complaining right now about the pip. We'll get back to it later. So, okay, now let me check. It still couldn't be resolved. It's really interesting because it's vent and I'm here. So let me start func start and start again. Okay, but at least right now you see don't give me this red things. But by the way, have I included JobLib? Yes, I included JobLib. Great. So right now, it should I have everything. I'm not missing anything. So what I'm gonna do, I'm gonna pick up some logs, and I'm gonna add some logs here because I want to see during the execution of my function some specific steps. It's like a print for you right now, and the logs will be immediately visible in the stream. So let me keep it as it is for now and just create a skeleton to make sure that it can get it. So the first thing, I want to hide this model path for now, and I just wanted to create model path locally. So model path is OS path join, and we have our so we are right now in the blob, not in the blob trigger. We are right now in the blob function. So I'm just gonna go one level above, then go to look for models folder, and in this models folder, I'm gonna pick up linear regression pickle. So linear regression pickle, great. And the model JobLib load model path, what I want to say here, I want to see actually the model. So when it's loaded, I want to make sure that it's there. For this part, I just gonna call it like this. What I want to do, I want to run my function and to make sure that it's able to retrieve the model and it's able to exactly get me the thing that I want back. So let me go there. Let me just open the sample dot. Yes, so let me just change something in it. So saving blob, which should trigger the function. And if I see it says, okay, let's check a look, trace back. Okay, it's not. But flowsheet process blob, okay. Okay, so it's working. You see, it's able to open the model and it just give me back what's there. So, okay, for now, this part is working. Great. this part is working for local development, so I'm capable of retrieving my models, I'm capable of opening it and open with JetBlink. The next thing that I want to do, actually, I want to get the data for prediction. So, and okay, now I know that the model is working, so I'm just saying here, model loaded. Let's pass it as it is. Now I need data. So here the problem is, if I'm gonna just use the old approach, numpy again from text.txt, I will get an error. And I will get error because it's expected to have a file. But what I'm getting, I'm not getting a file, I'm getting a stream of bytes. So for the sake of this, I'm gonna just use okay, let me keep the limiter. I'm going to use just Azurite CSV because we're going to work with CSV file. And the CSV file will be actually my input blob. And now input blob is just like a placeholder that's waiting to give me the bytes. So, and I want to call read function on top of it. And another thing that I want to do, I want to use the separator, and our CSV is comma separated. So like I want to do it like this. And to make sure that it's working, I want to add login, and I want to say, for example, second. Let me just show data. I want to see what it is. Data, and say data loaded. I'm doing this to make sure that I'm capable of reading CSV as a stream of bytes that's getting from my blob storage. So let me, now I don't want to work with a sample dots. What I'm gonna upload right now to the predictions input locally in the local emulator, I'm going to upload one of the files from, let's go from lesson 3 folder, batch data. Let me pick up, I want to pick up number 1. Number 1, upload, enter. So it should trigger my function. Oh, we see something happening. Let's check what's happening. So it's exactly saying there's something wrong. So let me go to start. It says exception error, expected file path name of file like object, got class bytes. So right now the pandas is complaining that it's expecting to read something different, but it got bytes. So as a quick fix, what I'm going to do right now, I want to convert it to the buffer. And for this, I'm going to use built-in library IO. So let me add it here. I don't need to add it to requirements.txt because this is built-in library like OS. So what I'm going to do right now, I want to make sure that I can put this in a nice package like this. So I updated it. Let's open CSV file and just move here. What I'm doing, I'm just like trying to trigger the function to make sure that something happened. Okay, so what it gives me now, it says model loaded, great, but it's giving me back empty data frame and it gives columns. So it's really, really looking weird. Why? Because it's picking up as header. So let me add here header equal none and do it again. I'm going to one CSV, I'm adding, removing, closing. Let's check. Okay, now it's looked much better. So we already have our files. Awesome. So now we have our data and data loaded correctly. So that's exactly my the thing that I'm expecting to get. Okay, so now I can remove this part. I can remove fstring. By the way, I can remove fstring from here as well, and if not from there as well. Probably I can remove it at all, but okay, let's keep it here. Okay, now we have our data. The question is, are the data is ready to be put into the model to get prediction? Not yet, because we are having a data frame right now, and I want to get an array. So let me create data array. So in this case, I'm just gonna take data, and I just use toNumPy function in it, toNumPy. And I want to make sure that it's working. So I do add-in login info as well. And it says, let's say, just want to see the data array. And you see how much time this local development setup saved me up, because I don't need to, everything that I exchange, I don't need to deploy the function and look whether it's working or not on the cloud while spending money on it. I can just do it locally immediately. So that's the beauty of it. Okay, great. So let me update the file again. So you see, it's not just triggered by a new file, it's triggered by the updated file. Okay, it looks nice. So it's creating actually an array that I need. Awesome. So then what I can do now, I can actually call prediction. So model predict, and I'm reshaping data to make sure that the data in the right formats. Now I can say, okay, here just, okay, data array created, just like this, data array created. So I'm go back to prediction, so prediction, and let me create this F string. So I want to see what prediction is. I want to see that my function indeed predicts something, right? And I'm saying, okay, predicted, oh, there, predicted value. Great. So again, oh, I close it. Let me open it again, move it, close it. Okay, so I get something. So let's see what's happened right now. So exception by executing attribute data frame doesn't have attribute reshape. Okay, so what's happened here? Let's check. Of course, because I called data instead of data array. Let's replace it with array and trigger it again. Do we have success? Woohoo! You see, we have predicted value. We almost done, okay, the next thing, so now prediction is working. What do I want to do right now? I want to say, remember our result is the string. So to make sure that I can write it as a string, I want to convert my NumPy array, that is my prediction, to this string. So I'm going to use just NumPy method for it. So let me say NumPy np, and then it seems to me it's to NumPy to string, or what the method is, NumPy to string. I don't, it's a to array, and there's two. Let me check briefly. NP to string. Yeah, there is array to string. Okay, we have array string. Okay, cool. Array NP array string, and then we passing our prediction. We're almost there. So it's called prediction. And then it's result. So let's check whether it's writing down result, resulted into login result. So let's update the file. Resulted into. So now it's looked like it's great, but one thing that I want to make sure that if it's working, it's actually, you see, generated the input output, and the output, that's exactly what we need. So it looks like we're almost there. The last piece that is left is now we are retrieving model from locally, but I don't want to do it locally. I want to retrieve it from the registry. So what I'm going to do right now, one thing that is missing, now I can say resulted into, I can remove this. Later we'll discuss logs, not today. I want to go to back here. So what I'm going to do right now, I'm going to say this is my workspace from config. Now I'm just removing this part. I don't need it anymore. I'm getting back to this one. And because this is the first time I'm running it, I want to point out to the workspace where my model is. Only type their own thing, workspace, and it's my VS. Without this, it will not capable of locating my model. So let's run it once again. Oh, let's load another file just to make sure that it's working. Upload files. Just let's pick it up random. File, enter. Fingers crossed that is gonna work. Let's check. Yes, it's looked like our function working. Great. So now what I can check, you see it creates it pulls Azure models and pull my linear regression model there. So that's the last piece that it can do. Now I can remove OS because I don't use it at all. Then I can remove workspace because I'm not gonna use it at all as well. I don't need it anymore. My model knows where to look for this function. So let's check. And if it's working, we gotta deploy it, and we've done for now. So let me pick up another file. Oh, not here. Let me upload another file. Enter, just waiting. Okay. Data predicted resulted into. Update here. Awesome, it's working. So that's what we have right now. We updated it. We make sure that everything was added to the requirements.txt. And now the moment of truth, we're gonna deploy it to the cloud. So I'm getting back to my extension. I'm getting back to the function. I'm getting back here to my function, Blob-trigger, and I just say deploy it. So make sure the requirements.txt is done, that this is done. So just let's check. So now it says I'm not going to create new function app. I'm just going to deploy to the same app that we have. It says, are you sure you want to deploy? Yes, I'm pretty sure that I want to do it. So checking up is deploying right now in the cloud. Fingers crossed. And if it's working, that we all set. And while we are waiting, it's happening right now, remember, it just grabs everything in this blob function parts, except the files that are not picked up by Git. And what it's doing is deploying our models to the cloud right now. So as soon as our models will be deployed, we could check it by actually dropping files to real blob storage and seeing what it's doing. Still in the process, it needs some time. It's downloading libraries, it's downloading files, Azure, joblib, Azure function. Make sure that it's going to run. So I'm collecting some packages, downloading them. While doing it, what I want to show, we need to wait until it's done. So that's what we did today. I want to talk briefly about the home assignment exercises. So again, you have exercises and home assignments. Exercises, there are 3 exercises for you, and they are making mostly for you to play around the tooling that we have with Azure CLI, with bindings for the blob functions. And the home assignment is to deploy the reach model as an Azure function. So it's collecting NumPy, it's collecting libraries, it's installing libraries. So let's check. We have almost 1 minute left, and then I want to make sure that it's working. Great. Stay with me for an extra minute. And by the way, while it's almost done, it's installed all libraries. In the meantime, Nancy, do we have any questions while we're waiting for the deployment of this function?
We did have something happened, like a question. Dania Meira, I hope I'm pronouncing this good enough.
Yeah.
She was following the steps with a bit delay because of the streaming.
Yeah.
And she's on the free trial, and she had 7 steps instead of 10 steps to deploy the app. So,
and that's where the question was, has she picked up? It depends on what she picked up. If she pick up the advanced setup, then it will be 10 steps, and she pick up simple setup, then it will be 7 steps. That's the difference.
Okay.
And I also added this to the, if I'm not mistaken, it should be lesson 3 theory. Let me check while it's still deploying. It's preparing output, copying files. I'm just checking like the documentation that I read in. Yes, because I'm saying create new function app in Azure Advanced. You should pick up Advanced, yes, because it gives you more things to add there. And we need this for the next steps in lesson 4 and the capstone.
Okay, then maybe if it's in the documentation, then it should be okay. We were thinking it was maybe because of the free trial.
Actually not. So the thing is with free trial, I also got some questions like, okay, do I get, okay, so wait 1 second, deployment is completed. Let's check whether it's working or not. Okay, so because that's the most important piece. Where I'm going right now, I'm going to real storage. Don't confuse it, it's local emulator. And now I'm going to the real storage, to the real one, to our blob container. And now I want to drop the real CSV file there. And see what our function is doing. Let's drop, enter. So creating, successfully upload. Sometimes it takes some time to process it. Let me check the predictions output. Sometimes takes some time, or probably we get something wrong. It could happen as well. So let me check. Sample that. So going back to the free trial, normally shouldn't be the issue, because if they limit a lot of things in free trial, there is no way for people to try it out. So there is no way actually for people to understand the full capacity. So it will be, let's say, the downgrade for Azure or any other type of the cloud provider. Okay, so let's check what's there for the logs, for the function. Let me check. Blob-triggered. So got back there. Ooh, it's working. We got it. So that's our call start. Let's check. I want just to make sure that it's working. Let's drop there 5 files. What's gonna, if it drop, I don't know, 5 files. Let's see. I'm dropping 5 files right now to our real blob storage. So the idea is that every hour there will be a file that will be dropping on the blob storage, in our function in there just to wait and listen to it and just generate predictions. So you see it's just loading files to the blob storage right now in the real time. And then after that, let's see, 1, 2, 3. Wait, we are missing one more. Let's check. Okay, now it's look like, so this is the prediction 158. Okay, that was our 158, 159, 160, 161, 162, 168. Great. And the thing is that it's working. So now probably any other questions, Nancy?
No, that was it.
And always, if there's some issues, there is always your team, your mentor there to help you. And as well, some of us that can also, from time to time, we monitor in the PyLadies Bootcamp channel. So if you need any help, let us know. So yeah, that's what we have. It's running, it's working, and now we have a function that actually listening to our blob storage. And as soon as something is dropped there, then you can deploy it. Let's say.
Awesome.
Yeah, that's it. And by the way, regarding the home task, I mentioned the home assignments. This will almost conclude our session. The home assignment will be for you to tasks. So go to the tasks. Let me open it like this. Yeah, so you will see if you're going to developing locally, you have run in Azurite, you need to stop Azurite and you need to clean Azurite as well. So you need to discover for yourself how to stop Azurite in Virtual Studio Code and clean up. And what does it mean stop and what does it mean clean up? What the difference? You need to see with your own eyes. Another thing is about bindings. So for now, what we're saying that we are open for any files that will be dropped to the blob storage. But now we have function that is waiting for actually something that looks like CSV. So if we get something like sample dot, we get an error. So what I want to update the bindings, this in bindings, so that a function will be triggered by CSV files only. And another story, you can as well, for example, update bindings so that a function will be triggered by CSV files with specific name pattern. So it's all about working with this specific file. Let me get to with these bindings, and I'm talking about these bindings, this that you're gonna play with path. And what we have else here, we have here how to, so now we have Azure Functions running, and it's running in Azure Functions app. So you need to learn how to stop it on your own, how to restart it, for example, if you stop it, how to restart, and then also how to remove it. And as I mentioned, home assignment, you're gonna create blob trigger functions, and you need to call it reach blob trigger, and you need to deploy it in a function app, reach blob trigger app. And then, so there are, let's say, to follow the steps that's exactly described in the theory. Okay, that's it from my side. Thank you very much for watching it. We did a great job together. We are already far, far away. We start with basic understanding what MLOps is and model deployment is, and we start working on energy deployments, oh my God, energy demands prediction, deployment of energy demand prediction model. We learned 2 options for now, how to do it in batch. So example, we want to predict for 1 week forward. So we waiting until the files will be collected, and we have collection on files, and we run in predictions once on the collection of these files with a pipeline. Or another option, every hour we have a file that's landed at our bulk storage, and based on this file, actually this function is triggered and produce a result that could be processed further. So the next lesson will be all about how to glue all the components together and what are the best practices, where you should watch out. And I think that's it. And then we will describe the capstone and what's waiting for you there. So once again, thanks so much. Thanks for staying a little bit longer with me. I do hope that we'll grab this 8 minutes back you next session probably. So we'll do our best, and have a nice evening and enjoy doing things. So I think, Nancy, you can stop our stream.
Yes. Have a nice evening, everyone. Thank you. Bye. Okay, should be done.